Functions are a mapping from one set of numbers to another set of numbers. So in this case, if we look at this first relation, we have -3 is mapped to 4, 2 is mapped to 1, 7 is mapped to -9, and 10 is mapped to 3. And when we want to find an inverse relation, we take those same ordered pairs and flip them around. So instead of -3 being mapped to 4, we have the inverse 4 mapped to -3. So if you think of this as a bunch of ordered pairs, this would be the x and this would be the y. But in an inverse relationship, now the x is 4 and the y is -3. And so to note that this is an inverse relation, we put a little -1 in the exponent. That means the inverse. If you think about it in terms of multiplication, you would have maybe 3 as your number, and the inverse of 3 would be 1/3. Okay, that's the reciprocal, or it's called the multiplicative inverse. But another way to write 1/3 is 3 to the -1 power, because this means that the 3 goes in the denominator, right? So the -1 power is a symbol that we use for inverse, and it's the same with functions and relations. So we'll use this -1. Okay, so if we look at the next one, we have G is 1, 5, 7, 3, and 2, 5, and to make the inverse relation, we just do 5, 1, 3, 7, and 5, 2. But notice what's happened here. The first one was a function, and its inverse is also a function. What does that mean to be a function? That means that for every input, there's a unique output. So for 1, the only thing that 1 maps to is 5. It doesn't map to 5 and 6 or 5 and anything else. It just maps to 5. And so in G is also a function, but when we take the inverse and flip all the ordered pairs, 5 now maps to 1, and 5 also maps to positive 2. And so 5 maps to 2 different things. That means that this G inverse is not a function. Okay, so we have to be careful about that. And you would want to, you could graph this to check, and you would see that it wouldn't pass a vertical line test, or just look at the ordered pairs and notice that 5 maps to 2 different things. Okay, so graphically we can see this represented. What is this first graph? It looks like y equals x cubed, maybe, something like that. Okay, so this is a function. When we take its inverse, what happens is it gets reflected along the line y equals x. Oops, y equals x. So it gets reflected along this line. If I can draw the line. Okay, so if you take this and reflect it over this line, then it becomes this graph down here in red. Okay, so if you flip this back over the line, you'd have what you started with. And notice the original is a function. It passes a vertical line test. And this new graph, which, as you would expect, is y equals the cube root of x, is also a function. Okay, both graphs are a function. Now let's look over here at this pair of graphs. The first one is probably something like y equals x squared. Okay, and it's a function. It passes a vertical line test. But when we flip it over the line y equals x, is it a function? So this is where it's flipped down here. This is what it looks like when it's reflected. And this is not a function. It doesn't pass a vertical line test. So you can see that in order for this to be a function, we're going to have to somehow restrict its domain or restrict its range. So y equals the square root of x. We would just take the positive values, right? Because originally this would be plus or minus the square root of x, and we would just restrict it to y equals the positive values, the square root of x, not the negative values down here. So you have to be careful about whether or not the inverse is actually a function. And so for functions that pass a vertical and a horizontal line test, we call them one-to-one. And one-to-one functions, when you take their inverse is a function. So we say a function that is one-to-one, it passes a vertical and a horizontal line test. That function, we say, has an inverse. It means it's invertible, it's one-to-one. Whereas this function right here doesn't pass a horizontal line test, which means that its inverse does not pass a vertical line test. So you can see this function is not one-to-one, it's not invertible, because its inverse is not a function. Okay, let's talk about using a function rule to find the inverse of a function. So we have a function, f of x equals x cubed minus 2, and we want to find the inverse as a function rule. So the first step is to just change f of x to y. Instead of using function notation, we're going to use equation notation. That way we don't get ourselves confused. So we're just going to change f of x to y. Y is going to be our temporary placeholder, and in the end we'll change it back. Okay, so now, talking about steps. After that, we will switch the x and the y. Switch x and y. And the reason we do that is because we're trying to flip it over the line y equals x. So what that would do in reality is to flip the coordinates. And you know that's what it means to be an inverse. It does the opposite. So first we'll do that. Then next step, we will solve for y. Okay, so we want to get y on a side by itself. Let's go ahead and add 2 to both sides. Divide both sides by 7. Okay, and take the cube root of both sides. Notice that the 7 is still in the cube root. That's important. Okay, lastly, after we get it back down to y being solved for y, we're going to write it in function notation again, so that way we can have our answer. So we'll write f of x, but use the little inverse symbol on the f. That way we know it's the inverse of f and not real f. Okay, so the inverse is the cube root of x plus 2 over 7. Okay, great. There we go. That's the answer. Okay, let's look at one more example. G of x is the fifth root of x, the fifth root of x plus 4 divided by 10. So first step, we're going to replace the function name with y, the whole thing. Okay, not just the g, but the whole thing. Okay, 5x plus 4 over 10. And then we'll switch the x and the y. X equals the fifth root of y plus 4 over 10. Oops, I'm sorry. I'm doing this wrong. The x plus 4 is in the numerator under the radical, but the denominator is not under the radical. Okay, let's try that again. Fifth root of y plus 4 over 10. Okay, it's important to get your radical straight and your denominator straight. Okay, so now we want to multiply both sides by 10. 10x equals the fifth root of y plus 4. Now we're going to raise both sides to the fifth power. And it's important to raise both your coefficient and your variable. So 10x raised to the fifth power is y plus 4. And I'm going to go ahead and distribute this exponent. So let's come up to the top. 10 to the fifth power is going to be 10 with 5 zeros after it. 100,000. X to the fifth power equals y plus 4. Last step, we'll subtract 4 from both sides. So 100,000 x to the 5th minus 4 is y. And lastly, to write our answer, we're going to replace the y with g inverse of x equals 100,000 x to the 5th minus 4.